So let's take a look at the event-driven architectures. We talked about this process of moving data around. And batch is not the greatest way to do things. What you'll find is that, and this is from Forrester, and I think it's totally accurate. Basically, you take a look, your X and Y dimensions. On your X dimension, you have time, right? How long something's been out there. And then on the Y-axis, you have the value of data to decision making, right? So as things come in real time, you can do preventative and even predictive things. You can actually say what's going to happen next. I can actually take action. I can do something. Within seconds, you can still take action. You can do something about it. But then minutes to hours, you're reactive, right? And then historical data is basically for things that are days and months. And that's where traditional batch process comes from. So imagine a fraud application. AT&T used Mongo and Confluent. I don't have their data here, and it's not publicly available, but just in general, they were using this for fraud detection. And they saved in 2019 over $1.2 billion in fraud. So imagine someone signing up for a service or coming in for equipment or buying an iPhone, and it's fraud. Do you want to find out the day afterwards, hey, you lost money, you lost $1,000? Or do you want to know right then and cut it off? The answer is you want fraud detection real time. So this is kind of how the value of the data is. And so I see it as a shift to, if we can get to the front end of the real time, the closer we get to real time, the more value we have. Everyone has like an Uber app or a Lyft that's using Kafka behind the scenes. It's all real-time data. You see where your driver is in real time, and that's super important. It makes it a lot better than calling for a cab and standing at the curb wondering where he is, right? Now they've actually come up with a curb app, they call it, for taxi drivers. But they're also using Kafka behind the scenes. So there's another question, like on the time value of data. Would you cross the street with information that was 5 minutes old? No. If it's a busy street, you could probably be hit by a car. You don't want to know what was there 5 minutes ago. You want to know now what's happening. And that's across the board. When you go into a bank, for example, you don't want to wait in a teller line. You want to take a picture of your check and have the deposit instantly show up in your account and be able to use it. And that's the kind of thing that Kafka is being used for. So all this across the board, real-time stuff, is kind of where Kafka fits in. So what is an event? We'll take a look at things like transportation, banking, retail. These are the things that we're looking at. When was something shipped? When was something bought? And it's all in real time. People are being notified. If it comes into one system, it goes into a Kafka topic. Anything that's consuming that data from that Kafka topic, multiple systems are aware of it in real time. You have to have multiple things happen at the same time. Everything is in sync. And what that does is it takes, without Confluent, this is the point-to-point integration where you have everything talking to each other and brittle type of things. I got to send this information to this database in real time, and it has to update this other app all in real time. But that means I have to code for each one of these integrations. And I've had people that basically said that once they get this working, they're afraid to touch it, because if I make a change in one system, it's going to break something downstream. There was a car manufacturer that couldn't sell a car for $100,000 for 6 months because there were so many hard-coded, 99,999 values in all the downstream systems that it would break. So they had to go fix their systems before they could sell the car. 6 months to fix this, and they didn't want to touch it. Those are the kind of things, real-world examples. So you go from that to this, where you have all these different databases and apps talking to Confluent through the connector architecture. And so any change that happens in one database through a connector, it's not an agent, but just connectivity information to the database, watching it for change data capture, pulling it in real time, and then notifying through consumer connectors or sync connectors to other databases to move that data through. It's a beautiful architecture, and it flows in real time. All that data that you would do through like a batch process.
Can I interrupt for a second?
Sure.
So this is centrally, right, one point. Is this like possibly the single point of failure?
Yeah, it would be if we had a single node on it. And a traditional, that's why Oracle has the rack. It came out with the cluster technology where you could actually distribute the workload across multiple servers. Kafka is the same way. So Kafka has broker nodes, and they have replicas that replicate that data. And so you basically have producers and consumers, and those producers or consumers are client applications. The broker just takes that information, puts it into a topic, then it keeps track of every consumer where it is with an offset value. and is able to keep track of all those consumers and where they need to go. You can horizontally scale, and you can vertically scale as well. So there is no real limit. We, just in the cloud, the Confluent cloud alone, we do hundreds of gigabytes per second. And so you can actually, there are places like Walmart, for example, does, I think, I forget what the number is, but Walmart is actually using Confluent, and they've used this architecture across the system. And I want to say they do 11 terabytes of data a day through Confluent. It's a tremendous amount of information flowing through. I don't know what that is in gigabytes per second or megabytes per second, but that's how we measure it. So it does flow, and it is scalable. It's not a single point of failure because we have a minimum of 2 typically in sync replicas. So if the first one fails, you fail over to a second that has that copy, and it's in sync, synchronous, right? So you can have 1 or 2, depending on how you want your architecture to work. So it's highly available and scalable. And so that was considered into it. It would be a bottleneck, it would be a single point of failure, but it was built to be distributed. Good question.
Yeah.